Hi, Year 11. This video is going to go over osmoregulation, how we control the water content in our blood. Now, we've talked about the kidney, its general structure, we've talked about the mechanism in the kidney through which the blood is filtered and through which the constituents of the blood, things like glucose and amino acids, water and salts, are reabsorbed. But generally, there's a mechanism that's going to support how well it does that reabsorption. And that process is osmoregulation. So water is essential to life. It's critical. But if you don't have very much of it, that'll be a problem. You need to hold on to it to let it do its job. But too much can also be damaging and an issue. So if you take in a large volume of water, if you literally go and smash out a couple of liters, assuming everything is pretty normal with your body, your urine output is going to rise pretty soon after that, and that will manifest for you by feeling like you've got to go to the loo. Um, on the other hand, when you really are short of water, let's say you're exercising heavily or you've sweated out quite a lot because of that exercise, you'll produce less urine. So, regulating the amount of water content in the body is absolutely something that your body's very capable of doing, and that process is called osmoregulation. So, the organs that can get rid of that surplus of water are the kidneys. Makes sense then that that osmoregulation process would be closely connected to them. Most of the water filtered by the kidneys is, as we've discussed in previous videos, reabsorbed, and that's going to be happening in the proximal convoluted tubule and in and around the loop of Henle, and that will happen in the nephron. And that will occur regardless whether you are overhydrated or underhydrated. If you are dehydrated, right, if there is a lack of water, most of the remaining water is going to be reabsorbed, okay, and that's going to result in a small volume of quite concentrated urine, and you'll know that because it'll be a bit more yellow or maybe even a bit brown. If the body is overhydrated, then little or no water will be reabsorbed, and as a result of that, you'll get a larger volume of water, and it'll be quite dilute, kind of clear in colour. So, what has the brain got to do with it? Because you're walking around with one of the largest supercomputers ever, your brain walking around doing stuff, okay, and it has a role in this osmoregulation. So, the kidney on its own can't do much, okay, it can't control the concentration of water in the blood, it can only really respond to signals that it receives from the brain. So the brain communicates with the kidney by sending a hormone, a chemical that's going to basically result in a physiological response. And that hormone is called antidiuretic hormone, or ADH. ADH is made by a part of the brain called the pituitary gland, and that's a pea-sized part of the brain. It's down at the base of the brain, and it stimulates the reabsorption of water from the collecting ducts. Now, like every hormone in the body, your body's mindful about having it at too high a level because it will continue to have an effect. So ADH is continuously being destroyed by the body. At any given time, how much of it is in the blood is going to depend on how much of it is being made at the pituitary gland and how much of it is being broken down. If the amount of ADH drops, so the amount being produced by the pituitary glands drops off, that will mean that the concentration in the blood will drop off. Okay, so when the water concentration, the amount of water in the blood is too low, ADH, antidiuretic hormone output, goes up. More water is going to be reabsorbed from the urine, and so the urine becomes more concentrated. If the blood becomes too dilute, so there's too much water, ADH output, the amount of ADH, will drop. Okay, and that will mean that less water will be reabsorbed and the urine will become more dilute. It takes about half an hour for urine output to reach a maximum after drinking a large amount of water. So if you go and smash out a couple of litres of water, all things being equal, about half an hour later, you're going to need to go to the loo. That's a function of the hypothalamus. So while the pituitary gland is going to make ADH, it doesn't sense changes in water concentration. There's another part of your brain called the hypothalamus. Okay, and it's just above the pituitary gland. So when the water concentration of the blood is going to fall, the hypothalamus is going to send a nerve impulse to the pituitary saying, sort it out, make more ADH. The release of the ADH can be slowed down by various substances. So an example of that is alcohol. Okay, alcohol inhibits ADH, and that's one of the reasons why alcohol is considered a diuretic. something that causes urine to be produced in larger amounts. Now, let's take this through a couple of scenarios, okay? Let's say you've got a normal water concentration in your blood, okay? If there is more water being taken in than water is going out, then some things are going to happen, okay? One of the things that's going to happen is there's going to be a rise in the concentration of water in the actual blood, okay? That will be detected by the hypothalamus. That will cause ADH secretion to drop. That will mean that less water will be reabsorbed by the kidney. That will increase the amount of urine that's being produced. The consequence of that will be that water loss is going to be bigger than water gain, and you'll get a drop in water concentration, bringing us back to where we started. At the same time as all of that, when we initially had that water gain exceeding water loss, there'll be some other physiological responses. So, for example, you will not feel as thirsty, and that will mean that you will take in less water, and that will lead to that water loss exceeding water gain. That's one part of our loop. That's how your body will deal with a rise in water concentration. But what about the opposite? What if there is a fall in the amount of water? So what if we start with our normal water concentration, but what if water loss exceeds the amount of water gain? Well, at that point, there'll be a fall in the water concentration in the blood. Again, that will be detected by the hypothalamus. That will cause ADH, antidiuretic hormone secretion, to go up. That will mean that more water will be reabsorbed by the kidney. That will reduce urine output. That will cause water gain to exceed water loss. And the consequence of that is that there'll be a rise in the water concentration in the blood. And that will bring you back to a normal water concentration. At the same time, other physiological responses. Last time out, you got less thirsty. Well, if there's more water loss than water gain, there's going to be an increase in thirst. That will increase water intake, and water gain will again exceed water loss. Critical to recognize that thirst has a role in being able to control your regulation of water. So when the body's dehydrated, the hypothalamus detects that, and that causes the feeling of thirst. That usually leads you to feel like you need to take a drink. So that's what being thirsty does. The hypothalamus, therefore, is having an effect on water concentration by regulating the balance of not just water loss by the kidney, but also water uptake by drinking. There's also the regulation of salt. So the levels of salt in the blood are regulated along with the levels of water in the blood. And the presence of too much salt in the blood is also detected by the hypothalamus. And when that happens, you'll get other responses occurring. So again, ADH, that antidiuretic hormone, will be released from the pituitary gland, and that will cause more water to be reabsorbed into the blood from kidney tubules. You'll also have another hormone, and I'm not going there right now, to be released, and that will cause sodium reabsorption in the kidney, and so it will cause sodium reabsorption in the kidney tubules to drop. Okay, so there's a separate hormone response that regulates this. Now, those two responses by the body means that you'll get production of a smaller volume of dark, concentrated urine, and at the same time, you'll feel thirsty, and that will help you restore your salt and water balances in the blood and maintain your internal environment. Too little salt in the blood has an opposite effect. ADH will drop, meaning less water is reabsorbed by the kidneys and instead will pass out of the kidneys and into the bladder, and the sodium is going to be reabsorbed from the kidney tubules, and that will increase the salt levels in the blood. So what you see there, guys, are feedback mechanisms that are effectively regulating water content. In essence, it's osmoregulation.